Okay, so let's take a look at this problem about Venus and the Sun. It says that the largest angular separation that Venus is as seen from the Earth, Venus from the Sun as seen from Earth is 46 degrees. And so let's draw a picture here. Here is Earth. We'll put Earth right there. We'll put the Sun over here. And then we'll put Venus, let's see, it has to be a 46 degree angle. So here's what we mean by 46 degrees is if we drew a line between the Earth and the Sun and then a line from the Earth to Venus, Venus will be out here somewhere. I'm going to try to draw it as best I can. So we'll put Venus right here. Now, the important thing about this is that if you are at and this, we didn't get to this in class, but the geometric situation, yeah, this is not drawn right. Just a minute, I need to move Venus just a little bit. The reality of this situation geometrically is that wherever Venus is, whenever it's at its maximal angular separation for the Sun, then this ray, the line that of sight between the Earth and Venus will be tangent to the orbit of Venus. I don't think this is still. I'll just do my best to cheat there. Okay, it's terrible, but so there's the orbit of Venus. It's not very good. Okay, so it's supposed to be tangent. I should have drawn this prior to, here, just a minute, let me try one more time. Let's see if I draw the circle and just hold the pen here. Okay, yeah, that looks so much better. Okay, the Sun isn't quite at the center, but you'll have to use your imagination. So the orbit, it will be, your line will be tangent. That means that this here, so this is the cool thing, is that this will be a right angle. So this is 46 degrees. This will be 44 degrees. So we're going to have to, and we're told that, let's see, the Earth to the Sun is 93 million miles. So I'm just going to put that as 93, and then you can tack on the million miles thing. Let's see, I need to figure out how to use my calculator now. Apparently I don't know. Here it is. Okay, so what we're going to do is we are going to, first of all, because this is a nice right triangle, I want to know how far Venus is from the Sun. That's an easy thing to figure out. We'll call this V for Venus. And since this is the angle, that's opposite over hypotenuse, and so that's going to be the sine of 46 degrees will equal opposite over hypotenuse. So that means V is equal to the sine of 46 degrees times 93. Multiply both sides by 93. So 93, I'm doing this on my calculator now because I can't, let's see, I don't know the sine of 46 degrees offhand. It's going to be a little bit more than, give me a break. Sorry, this calculator there. Okay, so V is 66.8986 million miles. Okay. We'll go with that. Okay, next one. It says Venus has, today, Venus has an angular separation from the Sun of 1 degree. How far is Venus from the Earth today? So this was actually the case the day that I gave this to you, but it's probably no longer the case today, or certainly not whatever day that you're watching this video. But here's the situation now. We have Earth over here. We have the Sun over here. Sun. And then Venus, here's the deal, is that the angle, so here's there. This is going to be a very small angle. So let's do this. I know this is larger than 1 degree, but we're just going to pretend. Now, here's the thing, though. For Venus to be 66.89 million miles from the Sun, it's going to have to be It's going to be inside Earth's orbit. But here, I'll draw Venus here for now. Oh, that's way too big for Venus, but it will work. So Venus is going to be going around the sun. Whoa, here it goes. There we go. So we're going around the sun like this. So that means Venus is either over here or over here. That seems like a side-side angle situation. In fact, it is a side-side angle situation. So let's just put Venus there for now and draw this in here. So it could be on the other side of the sun. We don't know. Well, we do know if Venus were there, then it's going to be shining very brightly because it's reflecting a lot of the sun's light. If it's closer to the Earth, then it will actually look dimmer because you'll only see a little crescent of Venus instead of the full Venus, like the moon. But anyway, getting back to the situation here, now we just have the 93 million miles. This we calculated earlier to be 66.8986. And we can use that to compute these various angles. In fact, let's go ahead and compute that angle. We'll call that angle, I don't know, we'll just call it A for angle for now. And so you have the sine of the angle A over 93 is equal to the sine of 1 degree over 66.8986. That means that the sine of the angle A is the sine of 1 degree over 66.8986 times 93. So let's see if I can do this calculation on my calculator. Let's see. So we have the sine. I know. Just looking at a blank screen, right? Okay, the sine of 1 degree. Let's see, times 93 divided by that thing. Okay, I got, that's the sine of my angle. Okay, so let me write that down. Sine of A is equal to 0.024262. That's what I'm getting. And that means that A, when I do the inverse sine on the calculator of that number, I get 1.39023 degrees. But bear in mind that that's the case where that is an obtuse angle. If, in fact, Venus were actually, let's see if I can grab just Venus here. Yes, I can. If Venus were over here, the situation would be quite different. You'd have a very obtuse angle instead of a very acute angle. And so if we want to know the other option, we could figure that out. It wouldn't be too difficult. Just subtract that from 180 degrees, actually, because that would be the reference angle if Venus were close to the Earth. So let's see, 180 minus that answer. And I got 178.61 degrees. So that would be if it's close to the Earth. So we'll do both of these versions. Then the final step is we're going to use the law of sines with those to figure out what this distance is. So so D for distance. That's what I'm really interested in, because that's the question, how far is Venus from the Earth? So what is that distance going to be? So I'm going to use the smaller angle because this picture looks correct for that angle. So this big angle here will be 180 degrees minus 1 degree minus 1 point. So the sum of the angles has to equal 180 degrees. So this will be 177.61 degrees. And now I can set up one more law of sines. So we have the sine of 177.61 over my distance is going to equal the sine of 1 degree over 66.8986. Do your cross multiplying and dividing and so forth after you get done solving for D. You get this, sine of 177.61 over the sine of 1. Those are all degrees. So that's going to be my distance. And now, if you're patient with me, I will type this into my calculator. So I know this is, if I was a YouTuber, or if I cared more, then I would probably edit this out, but I'm not going to. Let's see, sine of 177.61. Of course, those YouTubers, they have a whole team of people working with them to make them look good. I just have myself. Sine of 1. Okay, I think I got it. I hope I got it. And so D is 155.839. That's million miles. So that's if the picture looks like this. So what if Venus is actually closer to the Earth on this same line? It could be that, here, I'll draw this in here. It could be that Venus is actually over here. So if that's the case, then the situation looks sort of similar, except that, let's see, what's the deal here? In that case, I have this angle for A. Wow, so then the angle at the sun is extremely small, because the angle at the sun is just going to be 0.39. So let's do that. So you'll have this situation, sine of 0.39, I'll just leave it at 39 degrees. And the reason is that this here we go. I'll just draw this in here. This is 139 point, or no, I'm sorry, not 139. 178.61, which means the total of the angles in the triangle have to equal 180 degrees. And so you only have 0.39 degrees left at the sun. So it's a very small angle. But the math is the same from here on out. Just over D, sine of 1 over 66.8986. And that gives you this, that D, it's pretty much the same math. So 66.8986 times the sine of 0.39 over the sine of 1. So if you'll give me just a sec to figure out how to do this, I think I'm just going to have to type it in again. Oops. Delete. 8986 times sine of 0.39. 0.39 divided by the sine of 1. And let's see if that works out. 26. That seems reasonable to me. So I got 26.09 million miles. So depending on the situation, I believe when I looked up the information about how far Venus was from the sun, angular, on Friday, I think that it was the far one, because Venus was bright in the sky. You'll see it in the morning or in the evening. That's why it's called the morning star. But it's one of those positions, but I believe it was in fact that one. So quite a big difference in terms of the actual distance from the Earth.